Hey everyone, and welcome. Every single day, with just a click of a button, we send bits of information on this wild, invisible journey all across the globe. But have you ever stopped to wonder what's actually happening? Well, today we're going to trace that exact path from the moment you hit a key all the way into the cloud. So let's imagine this. You type in a website and hit enter, and bam, almost instantly, the page just appears. It feels like magic, right? But it's not. It's an unbelievably fast and complex process. So let's pull back the curtain and see exactly what's going on in those few critical milliseconds.
All right, so the first leg of our journey really has two main characters. First, there's the device you're probably holding right now. And second, there's a super powerful computer somewhere out there that has the information you want. In the tech world, we call these the client and the server. The client, that's you. Or, well, it's your device, your computer, your phone, whatever you're using. It's ground zero. When you type that URL or you tap on a link, your client is the one that gets the ball rolling and sends out the request into the world.
And the server, that's our destination. Just picture a huge, powerful computer that's on 24/7. Its whole job is to store all the files, the images, and the code that make up a website. It just sits there, listening for requests from clients like yours, and then sends back exactly what you asked for.
Okay, so this brings us to our first major hurdle. The internet is absolutely massive, right? We're talking billions of connected computers. So how in the world does your device know which one of those billions of servers is the right one? It needs an address.
And that's where this thing called DNS, the domain name system, comes into play. The best way to think about it is as the internet's phone book. See, we humans are good at remembering names, like Google.com. Computers, not so much. They prefer numbers, like this IP address here. DNS is the magic that translates the name we can remember into the number the computer needs to find its way. So now we've got the address. The next step is to actually send our message. But here's the thing. You don't just send one giant file across the internet. Instead, your request gets chopped up and mailed piece by piece, kind of like a super efficient postal service. And these little pieces are called packets. Imagine you had to mail an entire encyclopedia. You wouldn't try to cram it into one giant box, right? Of course not. You'd send it one volume at a time. The internet does the exact same thing with your data, breaking it into these tiny, manageable packets to make the trip fast and reliable.
Now, each of these little packets goes on its own mini journey. First, up at the application layer, your browser gets the request ready. Then, the transport layer chops it into those numbered packets so they can be put back together in the right order later. Next, the network layer stamps each one with that IP address we got from the DNS. And finally, the physical layer turns it all into electrical signals or flashes of light to shoot through actual physical cables. So our packets have zipped across the globe and they're arriving at their destination. But here's where things get really interesting. On the modern internet, that destination usually isn't just one single computer sitting in a closet somewhere. It's this massive, sprawling environment we call the cloud. And yeah, this really shows you how much has changed. Back in the day, a website might have lived on a single server. But today, huge services like Netflix or Amazon are spread across what we call the cloud, which is really just a huge global network of data centers all working together. Your request isn't just going to one machine. It's going to this gigantic, interconnected system. As you can imagine, this whole cloud setup created a brand new set of challenges. And with those challenges came a whole new career field, cloud security. This isn't about putting a lock on one computer anymore. It's about figuring out how to protect data and apps that are spread all over the world, facing all sorts of modern threats. Now, if you're even a little bit interested in a career in something like DevOps or cloud engineering, this next concept is probably the single most important thing you need to get. When you're using the cloud, who's actually responsible for keeping everything safe? The short answer is, well, it's complicated. It's a team effort. This whole idea is called the shared responsibility model. And here's the key takeaway. The cloud provider, think Amazon Web Services or Google Cloud, they're responsible for the security of the cloud. That means the physical buildings, the cooling, the networking cables. But you, the customer, you're responsible for security in the cloud. That means your data, your apps, and who you let access them. A really easy way to think about it is like renting an apartment. The landlord is responsible for making sure the main building is secure. The front door locks, the fire alarms work. But you are responsible for locking the door to your own apartment.
This chart breaks it down perfectly. The provider handles the big foundational stuff, but keeping your own data safe and managing who has the keys, that's all on you.
So, if you're the one who has to lock your own apartment door in the cloud, what kind of tools do you actually need? This is where we get into the nuts and bolts of what it takes to be a cloud or DevOps engineer today and how you hold up your end of that security bargain.
You might think the biggest threat is some super sophisticated hacker, but honestly, one of the biggest dangers is just simple human error. A misconfiguration. That's something like accidentally leaving a digital file cabinet open for the whole world to see, is one of the top reasons for major security breaches. The cloud is incredibly powerful, but that power also makes it really easy to make a simple, costly mistake. So to fight back against these simple mistakes, a whole new family of automated tools has popped up. Now I know, these acronyms look like a nightmare, but they're the core toolkit for any cloud job. Let's break them down real quick. A CSPM is like a security guard that's constantly checking your cloud setup for those dangerous mistakes. A CIEM is all about managing the keys, making sure the right people have access and nobody has more than they need. And CWPPs and CNOAPs, they're basically bodyguards for your actual code while it's running in the cloud. So look, understanding how a packet travels is the foundation, it's the why. But learning how to use these modern security tools, that's the how. It's how you take that foundational knowledge and actually apply it to build and protect the secure, amazing services we all use every day. So there you have it. From a simple click, your request gets chopped up, given an address, and sent on a lightning-fast trip to a massive cloud where its safety is a shared responsibility. This journey is only getting faster and more complex. So the real question is, how are you going to help build and protect its future? Thanks for joining me.